Today we will be covering k-way merge. Okay, so basically it is a pattern that is used to merge k sorted list or arrays into a fully sorted list. Okay, so it extends the idea of merging two sorted arrays like in merge sort to k arrays using a min heap. Okay, so let's say we are given arrays 1 2 3 and 2 4 5. We need to merge them. After merging, it will be 1 2 2 3 4 5, right? After merging, it should be sorted. So this, in this type of questions, we will use min heap. Okay, so currently there are two arrays only, like, but we can have k arrays also. So what is the idea basically? Instead of comparing all the elements in all the arrays, we will maintain a min heap of the current smallest element, right? Let's say we are having these two arrays. Now we will be having a heap. In that we will be storing the elements from both the arrays, right? Let's say 1, then 2, then 3, 4 and 5. So one by one we will get the minimum and store in the result, right? So in this way we will be using min heap, and in that we will be storing the elements so that we will get the minimum first. Okay, minimum first, and we can add it in our result. Okay, so we will add all the elements from all the arrays in the min heap, correct? After that, always extract the minimum element from the heap. That's what we are doing here. Push the next element from the same list. Okay, so we will be solving this example. In this I will tell you step by step and repeat until all elements are merged, correct? So basically we are having one problem, that is merge k sorted arrays in one sorted array. Let's say we are given this example. Now we are given 1 4 5. This is first array. Second array is 1 3 and 4, and third array is 2 6. Okay, so we will be having one min heap of size k, correct? So basically we will be maintaining the size k. K is what? K is 3 in this case, right? The number of arrays, correct? So first we will be having min heap of size k, right? After that push first element from each of the k arrays into the heap. Let's put 1 from this, 1 from this and 2 from this, right? But with the heap we need to add anything else also, right? Value, array index and the element index, right? So that we can easily know like this element belongs to which array, this element belongs to which array, this element belongs to which array, right? So basically we will be pushing the pairs, right? Pairs of what? Pair of value, the array, which array and the its index in this array. Okay, in array, correct? Let's say if we are pushing 1 from this, it will be 1. Array is 0 1 and 2, right? It has 0 index, and what is the index of this element in this array? It's 0, right? So we will push this 1 0 and 0, right? After that what we are doing, we will push the next element, first element of the next array. So it will be 1 1 and 0. Same with the next 2, and then what? It's 2 and 0, correct? So what is the benefit of pushing all the elements? First element basically. After pushing all the elements we will get the minimum, right? We know that each array is sorted, right? So the first element of each array will be the minimum. So first element of each array is minimum, and we need to find the minimum from all of the arrays. So we are pushing the push first element, that is the minimum of each element, each array in heap, right? In min heap, right? After that we push the first element, that means the minimum elements. After that we will remove the element, right? We will remove the element. We will get what? We will get the minimum of all, right? So we will get, in this case, 1 0 0 1 0 0. That means this element, right? We got this. We will save it in some result, let's say 1. After that we need to push the next element from this array only. Okay, we will push 4. Okay, remove this, then push 4 0, and first is the index of this element. Got it? Again we will remove the smallest element, because this is the min heap. We will get the minimum at the front. So now we will get what? This element, that is 1 1 and 0, right? So what is the array? This is the array, this is the element, right? So again we will push this 1, and we need to push the next element from this array, that is 3. We will push 3 here. Okay, that is 3 1 and what? First is the element index, right? In min heap we are adding one element from one array at one time. If we remove that element, then we need to insert next element from that array, right? And we have done with this one. Now this is the current min heap, right? So it will remove the next smallest element, that is 2 in this case, right? It will remove 2 2 0, right? Now we need to insert next element from this array, that is second array, right? That is 6. So 6 second, and index of that array, that element in the array, is 1. Correct? Now at each point or each step you can see these 3 elements belong to different arrays, right? So now these are the 3 elements, that is 4 6 and 4. Okay, so now again it will remove the smallest element. It will remove this element. Okay, 4 0 and 1, this one, add it here, 4 0 and what? 1. We got here 3 and 4, and so on. Okay, like this it will complete all of the elements from all of the array, and we will get the answer in the sorted manner. Got it? The approach: when heap is not empty, pop the smallest element. We are popping the smallest element, right? And add it to the result array. We are adding in the result. After that, push the next element from the array into the heap. Okay, that's what we are doing. We are checking the next element. Like in this case, we are pushing 4 and 6, right? So this is the approach. Question is merge k sorted list. Okay, so here also, like, we need to push 3 things, that is value and the array index and the element index, right? Element index, correct? So we can make a node class node in which we will be having these values: value, index, array index and element index, right? And we will be pushing this node for each element in the priority queue, and we will be comparing using the value of each nodes, correct? So what is the question? The question is given with the linked list. Okay, so let's see. This array is just for the explanation. Okay, we need to use linked list here. I hope you got the logic. So let's see the question. We are given the linked list. Okay, linked lists we are given, and what is the class? This is the class, this is the definition. So in the node we are having one value of the node. This is the node, let's say we are having the value, the next node, and that's it. Okay, this is the constructor. Okay, so we are given the list, that is 1, 5, 4 and 5. This is one list. 1, 3 and 4, this is second list. 2 and 6, this is third list. Same as the array as we did above, just we need to consider this as a list, right? So explanation I didn't copied. Yeah, I copied. Okay, 1, 4, 5, 1, 3, 4 and 2, 6, right? 1, 3, 4, 2 and 6. Now what was the first step? First step was min heap, and we will maintain the size of k, right? And second, what is the second step? Second step is we need to check the values. We will push these first values, right? So push first node of all the list, correct? And third step was poll the minimum one, remove the minimum one and push in the result, right? We will get the minimum, and after that check if next node is there in the list, in list. If it's there, then add it, right? Like we are removing this one, then we are adding 4, correct? So these are the ways, these are the steps. Now first we will be having one let's say first loop will be there. Okay, loop for what? For pushing first node, right? First node of all list, correct? Second part will be a while loop, and in this we need to get what? We need to get we need to get the minimum, right? So we will check if min heap is not empty, right? Till that we will be running this while loop, and within while loop what we are doing? We are removing the minimum element and we are pushing it in the result, right? So remove, poll the element, add in result, and add next node in PQ, priority queue or min heap, right? So these things will be in linked list, right? We need to check. Okay, if it's clear, then we code now. Shall we code? So these are the definitions. We will be using this. Okay, so for the next we will be using next. Okay, let's say current dot next, we will get the next element, and current dot val, we will get the value of that element, right? So let's, and in the priority queue we will be sorting them on the basis of their value with this, correct? So let's write the code. Okay, so here we will be having, this is the question, right? Okay, so let's write the base condition first. In every question, try to find the base condition and write it, right? Let's say if root equal to null, like that. And thus we can say if list equal to null, or the length, right? List dot, it's list dot length equal to 0, then we will be returning what? Null, correct? Let's make priority queue. In this we will be passing list node, correct? List node we will be having in the priority queue, that is min heap, and we will be comparing them on the basis of their value. Dot val, priority queue AB, we will be passing AB, okay, and AB are the nodes, and we need to compare on their values, right? val a dot val minus b dot val. This will return in the ascending order, right? So we will get the min heap. Got it? After that, we will add the first node of all the list. So list, let's apply the for each loop on this list node. Okay, so if node is not equal to null, we will add it, right? So add it in what? In min heap dot offer what? Node. Correct, adding first node of all the list nodes as they are smallest. Correct, because their lists are sorted, right? Let's write it also, lists are sorted. Correct. So after that, after inserting the first elements, we will be removing it and adding it in the result. Correct. So let's make the result list node result. We will make a new list node. Okay, the node with the value 0 and a pointer will be there, okay, which will point and which will traverse through the elements, okay, which we will basically pull. It will be traversing the elements from that list. Okay, the current equal to its result initially. Okay, then while loop will be there, right, for removing the elements and for whole procedure basically. While min heap is not empty. Correct. In that, what we are doing, we are removing the element. First step was that list node, let's say min node is this, and we are removing from min heap. Okay, so we got the minimum node. After that, we will get the node, that is, sorry, we need to attach this node in the result. Correct. So adding in the result. How can we add in the linked list? So we are having this pointer. Correct. So current dot next, that is initially pointing to the result. So we are adding the new node in the result. Okay, dot next will be equal to what? Min node, right? It's correct. And now current will be this node. Okay, current equal to current dot next for adding the next elements, right? Let's say if we are having this node initially with value 0 and we need to add 1, we can simply do this is current. Okay, current dot next equal to 1. This is 1 dot next equal to 1. Okay, now we will do what? We will make this as current, so that in next step, let's say we are adding 2. So current dot next equal to 2 now. Got it? The simple adding node formula, we can say current dot next equal to new. Okay, and current equal to current dot next. Okay, so now what tells? Check if next element is there in list or not, right? If it's there, then we will add in the priority queue, that is min heap. If min node dot next not equal to null, in that case we will be adding in this min heap. Correct, that is min node dot next. Correct. Like in this example, while we are removing this 1, we need to add 4. Correct. So that we will cover all of the elements and we will get minimum at each iteration. Correct. That's it at the end. we will return what? Return this result. Now what we need to return? Result is the head of the list. Let's say initially we have made this result. Okay, result is pointing to this node. Now what we need to return? We will return result dot next, that is this node. Okay, from this node we will return, as this is the new sorted merged list, correct? So we will return result dot next. Let's run this. What is the issue in this? Okay, this should be under the braces. Okay, it's accepted now. Let's submit this. It's accepted. See, basically what we need to do in this question, we need to merge the sorted list. We know the lists are already sorted, so we need to compare the elements. Initially the first elements, then we are adding what? We are adding the first elements in the mini heap, so that we can get the minimum of all. After that we are just inserting the next element from that list. Then again we are comparing the minimum, then again we are getting the minimum and adding in the result. What is the time complexity of this? It will be this for loop. It will be what? We are adding k elements, right? We are having the k list and we are adding them in the mini heap, so it will be O of k, correct? After that, what is the time complexity of this while loop? And this, basically we are traversing each and every element, correct? So it will be of n first, right? And within this we are removing the element from this mini heap and adding it, right? So it will take multiply what? Log of size of q, that is k. So overall it will be of n plus of n multiply by log of k. So we can remove the, we can take the dominant term, that is n log k. We can ignore this one. So this is the question, find k pairs. It's not basically this merge question. Okay, this is basically the combination of this merge, the logic in the merge and this min heap logic. Okay, so basically we are given the two integer arrays nums1, nums2 sorted in non-descending order, that is ascending order. Okay, and an integer k. Define a pair uv which consists of one element from the first array and one element from the second array. We need to return k pairs with the smallest sum. Okay, let's see the example. So we are given two arrays nums1, that is equal to 1, 7 and 11, right? Nums2 2, 4, 6. We need to find k pairs, k smallest pairs, right? So what can be the pairs? Let me write here. 1 plus 2 can be one pair, right? 1 plus 4, 1 plus 6, correct? 1 and elements from this array, right? The second can be 7 plus 2, 7 plus 4, 7 plus 6, right? And 11 plus 2, 11 plus 4, 11 plus 6, right? And these are sorted. These both arrays are sorted. We need to find k smallest pairs. Can we do like this? Like we will take this one from this and we will do what? We will make pairs with every element from this. Let's say 1 plus 2. Okay, that is 3. And we will add in the priority queue. Okay, in the priority queue we will add what? We will add, again we need to add the what? Some kind of pair. Let's say sum, the index of the element in nums1, the index of the element in nums2, so that if that element is done, we can move to the next element from that array, right? Correct. So this is the pair we will be using in priority queue, right? So let's see In the priority queue, first we will add what? We will add 3, correct? And pair will be 3. And what is the index? It is 0 and 0, correct? I and j are 0 and 0. The next we will add 1 plus the next element in nums2, 4, let's say 5. Okay, 5, 0 and 1, correct? 1 plus 6, that is equal to 7. So 7, 0 and 2, right? Window is maintained of size k, correct? So first we will add these pairs. That means one element from the num1 or num2 anything, and others element from the second array, correct? And we will make the combination, we will add in the priority queue. Now after this, I can say we will get the minimum pair of all the pairs. Can I say this? We will get the minimum pair of all the pairs because I am using this first element, right? First element is the smallest, correct? And all elements of this, so obviously I will get the minimum pair out of these pairs, correct? Because this is sorted. So after that, let's remove this. When k is maintained, we will remove the element. We will remove the minimum, that is 3. Okay, 3 is the smallest. We will add in the result. Okay, let's add in the result. So we added 3, 0 and 0. Okay, now we need to add next pair, right? Now we will move to what? We will move to this 7, right? Correct? Again it will make the combination, it will insert it, right? So we will add what? 7, and what we have removed? We have removed 0 and 0. Okay, so we can make 7 with this 2, correct? So we will get 9, right? Let me explain the approach first. 1, 7, 11. Now how we are getting all of the elements? 1, 7, all of the pairs, right? nums2 equal to, what was the elements? 2, 4, 6. 2, 4, 6. Okay, in the first iteration I am doing what? I am taking one element. Let's say we are taking from here. Okay, first element from here or here, anything. Let's say from here. Okay, one element at one time, and all of the elements from this. Okay, so it will be 1 plus 2 equal to 3, 7 plus 2 equal to 9. Now what next? 11 plus 2 equal to what? 13, right? In this iteration we are getting these elements. Okay, in the next iteration, the second iteration, what we are doing? We will be removing the smallest element, that means 3. We will remove this. Now what we need to do next? We have taken all elements from this, right? So already 1 is there, right? We will move to the next from this array, right? We will go to 4. So it will be what? 1 plus 4, correct? We have took this element and made the combination with all of the elements in what? nums1. Now we need to take the next element and make combinations, okay, with the element which we will remove. Let's say 3 we removed. For 1, it's done. Now, okay, right? In the first step we have taken all of the elements from nums2. In the next step we will be taking next element from this. Okay, so it will be 1 plus 4, 5. Okay, now we will again remove the smallest, that is 5. Again we will take the next element, that is 6. 6 plus 1, that is 7. Okay, and this way we will get the first 3 smallest pairs. Two things basically in this way, two things are maintained. First is this all elements, all pairs we are getting, okay, and second is we will get the get the least sum pair at each time. Okay, because this array is sorted and we are proceeding by one step only. Okay, before coding, let me complete this. It's completed already. How we got this 3 pairs, right? And in the priority queue we will be adding 3 things. First is sum, and second is I, and third thing is j. Okay, to move to the next pointer, right? Like here first we are taking this 2 and combination with all of the elements in nums1. In the next iteration we will take this next element. So let's say this is j, so we will take j plus 1 in the next iteration, right? We will take 4 and check the combination, right? As here we removed 3 and here we are having 1 from the nums1, so we will make the combination with this 4 and 1. For this we need to maintain I and j, right? That is index from nums1 and nums2. Okay, so let's code it. First, what will we will have? We will have the result, right, which we will return. So it will be of type list integer. Got it? Let's say result array list. Correct. After that, what is the base condition here? Try to add base condition first in every question. So we will be checking the length. Okay, length and this k. So nums1 dot length, if it's equal to 0, same with nums2, right? If that is equal to 0, or our k is 0, that means we need 0 elements, 0 pairs. So we will return this result as it is. Okay, that means the empty. After that, let's make the priority queue. Priority queue. What is the type? Type will be now array, as we need to push pairs, right? The sum, I and j index. Main heap equal to new priority queue. Now what is the comparator? What we need to pass here? Array. What we will have? We will have the sum, the I index, the j index, right? On which parameter we need to compare them? On the sum, right? So a and b. Let's have the lambda function. After that, what? Integer dot compare, right? In the comparison we will pass a of 0 and b of 0. That means the sum. After that we will add the for loop. We will add the elements, right? What we were doing here, we will add the we will make the pairs. Let's say first element from this nums2 and all of the elements from this nums1, right? So let's make the pair. Int I equal to 0, right? I should be less than, now I should be less than what? Anything. Let's say we are applying on this, we are taking all of the elements from nums1, but let's say k is we need k as 2. So we will be getting, let's say, let me explain this part. We need to optimize, right? Here in nums1 we are having 1, 7 and 11, right? But we need only 2 pairs, so we will be checking first 2 elements only, right? Why third? Correct. Got it? So we will be checking minimum of both, that means the length and the k. Math.min nums1 dot length and k. We will take minimum of both, and then what? I plus plus. Correct. Now min heap dot offer. In the offer, what we will do, we will make the array, right? New int, and the first parameter will be the sum, right? That is nums 1 of I plus, we will take the what? We will take this first element, that is nums 2 of 0. We will make this combination with all of the elements in nums 1, correct? Nums 2 of 0, right? This is the first parameter, that is the sum. The next is I, the next is j is 0, right? In this step, got it? Initial step, taking one element from nums 2 and making pairs with nums 1 elements, right? And adding it in queue. In min heap we can write only key elements, only first k pairs, right? Got it? Now this is the step, this is the optimized step, okay? If you will do this, interviewer will be happy. Got it? So we inserted the initial elements. After that, what was the step? We need to remove the element, right? So we will do while loop. While what? Now we need to get what? We need to get k elements, right? K pairs. So we will stop when we get our k pairs, correct? So let's write it. While k is greater than 0 and our min heap is not empty. Min heap is not empty, correct? Right. So after that, what? We will pool the current element, let's say equal to min heap dot pool. Got it? We will return the remove the smallest pair. Now we need to add this in our result, correct? In the result we need to add just the numbers, right? Like 1 and 2. So we will get the numbers using these indices, right? We added I and 0, that is I and j. So int, let's extract that, will be current of 0, sum will be this, right? Int I will be what? I will be current of 1, right? And ij will be, that is the index of nums 2, will be current of 2. Let's write it here. Index in nums 1, index in nums 2. Got it? Now we will get the element and add it in the result dot add. Now we need to add as a array list, right? Because this result is array of array list, correct? So we will use the method what? Arrays dot as list, and in the list we will be passing what? Nums 1 of I, and the second element was nums 2 of j, correct? We will add this as a pair, as here we can see 1 and 2. Got it? Now add it in the result, added smallest pair in the result. After that we need to push the element, right? Which is the next. Let's say we have made the pairs with 2, right? Now we will move to the 4 and make the pair with the same element, that is this element, right? 1 2 was the pair. Now we will check 1 and 4 because this will be the next smallest, right? So we will move this j pointer. Okay, so we will check if j plus 1 is within the bounds, that means j plus 1 is equal to nums 2 dot length, then we will do what? We will add in the, let's first make the new sum, right? New or sum, which will be equal to what? Nums of 1 of I, correct, plus we need to increase j, right? Nums of 2 of j plus 1. Got it? We will get the new sum, right? 1 plus 4. We will increase this j pointer. Okay, after that we can simply add it in the min heap, right? Min heap dot offer what? New int, right? In the int we will be passing sum, new sum I j plus 1. That's it. Okay, at the end we will be returning what? Return result. That's it. Let's run this. Compilation error, nums2, where nums, it's nums2. Wrong answer. Why so? Okay, so here we are checking this k greater than 0, right? But after adding this in the result, we need to do k minus also, right? Because we got one result, we got one pair in the result, so we will reduce this. Let's say initially k was 3, after that we added one pair, now we need only 2 pairs, so we will do k minus. Okay, it's accepted now. Let's submit this. Okay, accepted. Understood, guys? Next, smallest pair. Okay, increase pointer in nums2. Okay, as got it, guys. Okay, then what is the time complexity here? See, for this loop it will be what? The time complexity, it will be, it's running k times, right? Basically, let's say minimum of nums 1 dot length or k, right? So this is the time complexity of first loop. After that, this while loop is there, right? And this, what is the time complexity? Here we are doing what? We are checking what? We are checking this, basically k only, right? So it will be of k into log k. Got it, guys? So overall it will be addition of these, minimum of nums 1 or k, and this overall it will be this one only. Okay, k into log k.